we are. We're at our fourth video of trying to figure out trig ratios for angles that are negative or angles that are bigger than 90 degrees, which are outside of a right triangle, and trig ratios are supposed to be for right triangles. So how does this work? That's what we're trying to figure out. And so I've added a little bit to this slide. We have been looking at cosine 30 being 0.866, what that means. Cosine 150, again, bigger than 90. How is that a right triangle? How do we get cosine ratios? So hopefully we sort of looked at this cosine. For this video, I've added ideas about sine. So you could check these if you want on your calculator. You could do sine of 30 degrees, you'll get 0.5. Sine of 150, you'll get 0.5. So you notice, again, like cosine, these angles have similar sized sine ratios. They're all 0.5 big. So the ratio of the opposite to the hypotenuse is a half, basically. But sometimes it's positive, sometimes it's negative. Why does that happen? How does that happen? That's what we're trying to figure out. So in the previous video, we talked a little bit about sort of having a point on our coordinate plane called XY that goes through a certain angle. And if we have that point and we draw this right triangle down to the x-axis, this side of our triangle is our x, that's our adjacent. This side of our triangle is our y, that's our opposite. And we can look at r. Yesterday we were looking at the unit circle to simplify things, so we're going to look at the case where this is always 1. And if we do that, what is our sine ratio? Well, our sine ratio is opposite over hypotenuse, which turns out to just be the y value of that point. And if we look at cosine of theta, we're looking for the adjacent over the hypotenuse, and we get x over 1, which is really just the x coordinate. So when I have a hypotenuse of 1 on the coordinate plane, it turns out that the sine for that angle is the y value, is the height of that triangle. And the cosine is just sort of the length of the base of that triangle, the x coordinate. Okay, so again, now we're going to investigate how that plays off in these guys right here. So we're going to start with, so here I have sort of these 4 angles. Do you see, hopefully, that this right here, this is my 30 degrees. And we said that this right here is 0.5, and this is 0.866, and this is 1. Because we said this is a unit circle again. If the hypotenuse was double, all the sides would double because they're just similar triangles. Right? So the ratios then would still be the same. Because if this side becomes 1, if this becomes 2, this becomes 1, then we still have 1 to 2. We still have a 1/2 ratio. Okay, so then when we look at this, it says that cosine of 150 is negative 0.866. Sine of 150 is 0.5. So if we come over here and we look at this picture, that should make sense. When I think about this, again, my sine is my y value, and this triangle right here is the same triangle. It's just flipped over, and the y value right here is still 0.5. My hypotenuse is still 1, and the sine ratio is still 0.5 over 1, or 0.5. Now the cosine ratio is going to be the same size, but now it's opposite in sign. It's going to be negative 0.866. Whoops, didn't mean to do that. Let's go back here, 0.866. Because the triangle is the same, so the length is the same, okay? And that's why when we look at these, but it works because they have the same reference angle. That's the piece we're missing. If I'm at 150 degrees right here, that has a reference angle of 30 degrees. And if I have the same reference angle, I will have the same sine ratios and same cosine ratios, but maybe positive or negative depending on where we are. That was sort of where we landed. For any angle in standard position, the cosine and the sine are the same size as the cosine and sine of the reference angle. And then what changes, maybe it could be a positive ratio or negative depending on what quadrant the terminal side of the angle is in. So again, the terminal side of 150 goes from here to here. It ends right here. We're in quadrant 2, and anytime I'm over here, my sine ratio will be positive because my y, I don't care where my triangle ends, My y will always be positive, and the cosine ratio will always be negative because the x coordinate or the adjacent side will be negative, right? So let's see what happens when we go to quadrant 3, right? 210 degrees. It looks like both cosine and sine ratios are negative. So again, the same size because a 210 degree angle has the same reference angle. It's kind of hiding under this 0.866, but it's there, it's 30 degrees. And that 0.866 is still the cosine ratio because again, we're on a circle, so the radius is always 1, so my hypotenuse is 1. And then the y though, right here is going to be negative. So sine of 210, this is my 210, has the same reference angle as a 30. And so, but in quadrant 3, both cosine and sine are going to be negative. Pause the video, see what you think about this quadrant right here. What do you think we're going to get, positives or negatives? And if you're back, hopefully you could see that the cosine ratio is still going to be positive because the adjacent side is still in the positive x. But our sine of negative 30, because this is the negative 30 degree angle, we go clockwise for negative angles, and we go counterclockwise for positive angles. And this y coordinate right down here, if I'm right down here, my y is going to be negative. So I'm going to have negative 0.5. And you can see that is what we got. If you do these on your calculator, you will get those answers, right? And here's the reason why. Because it's about the terminal side. That's how we figure out positive or negative. And that's really the point of this. One thing you want to remember as we're trying to figure out positive and negative is as we draw triangles based on our terminal sides, let's say my angle terminated in quadrant 2, I'm always going to draw my triangle because here's my reference angle. It's always down here, and my triangle should look like that. If my angle terminated in quadrant 3, again, I always draw to the x-axis, boom, and this would be my reference angle, right? The reference angle is down there. If I terminated in quadrant 4, again, my reference angle is going to be down there in the corner. We always draw to the x-axis, right? And so you can see this is my first quadrant one, bow ties and butterflies. My triangle should always be a piece of a bow tie or a butterfly. I also like to say, so not this, because what I don't want to do is go this way. Whoa, whoa, because then it's like an hourglass and your time is running out. You don't want that. Not that. Okay. So let's try a couple examples quickly. So draw the angle in standard position, draw the triangle using the reference angle, and then figure out will our sine and cosine be positive or negative. So let's try 240. So you should pause the video and see what you get. So I know if I'm doing 240, 180 is right here, 270 is right here. So 240 is somewhere down here, somewhere there. And then I can draw my triangle, always to the x-axis. Here's my reference angle. Can you figure out the reference angle? The reference angle would be 60 degrees. And so what I know though, is if I am trying to find the cosine for this angle right down here in the corner, that's going to be the adjacent side, and this is going to be negative, and the hypotenuse is always 1. And the opposite side is going to be negative. So cosine of 240 will be a negative number, and sine of 240 will be a negative number. And you could check those on your calculator. For a challenge, another angle that will have the exact same sine ratio, well, it would be the one that has the same reference angle, for sure. But also, well, for sine, it would have to have the same y value because it would have to have the same opposite side, right? So I think what's going to happen for that challenge question, I'm going to come over here. I need to be somewhere in quadrant 4 because I still want sine to be negative, right? I need to have a negative sine, and I'd still have to have a 60-degree reference angle. So as a challenge question, where would I be at if I was down here at 60 degrees and I think 300 degrees? You could check that with your calculator. Do you get the same sine ratio for 240 and 300? Check that out. Okay, let's try another one. So 160. Again, you could try this on your own. We're going to go to, that one for me is in quadrant 2, again, because this is 90 and this is 180. So I'm somewhere here. Oops. And when I draw my triangle, I'm going to draw this way. And again, my cosine ratio is about this side. This is going to be a negative. So cosine of 160 will be negative. And then my sine, the y value is going to be a positive number. So sine of 160 will be positive. And you could check that with your calculator. My guess is you will get those answers. And also, here's my other bet. If you type in sine of 20 and cosine of 20, the number part will be the same as for cosine of 160 and cosine of, or sine of 160, because they would have the same reference angle, because this reference angle right there is 20 degrees. So hopefully you can try some questions on your own now.